In this lesson, we will add, subtract, and multiply matrices. A matrix is a rectangular array of numbers usually displayed within brackets. The dimensions of a matrix are the numbers of rows and columns in the array. Here we have matrix A, which is a 2 by 3 matrix because it has 2 rows and 3 columns. Each number in a matrix is a matrix element. You can identify a matrix element by its row and column numbers. In matrix A, A12 is the element in row 1, column 2. So A12 is element 4. So what is the element B23 in matrix B? Remember, element B23 is row 2, column 3. So the element that is in row 2, column 3, here's row 2 right here. Here's column 3. At the middle of that, the element is 8. Two matrices can be added as long as they have exactly the same dimensions. The sum of two matrices with the same dimensions is the matrix obtained by adding the corresponding elements of the two matrices. In these matrices, the element that corresponds with the 3 is the 5. So we will add 3 plus 5, and that becomes the top left element. The 2 and the negative 6 correspond with each other, and they will become the top middle element. Negative 5 and 2 correspond with each other, and we will add them together to be the top right element. 6 and 4, 1 and 5, those are the middle elements. 7 is the middle right, negative 4 is the middle right, 7 minus 4. Negative 2 plus 1 will be that element. 0 plus negative 1 is down here, and 5 plus 0 is down here. Now the results will be the sum of all of these. So 3 plus 5 will be 8. 2 minus 6 will be negative 4. Negative 5 plus 2 is negative 3. 6 plus 4 is 10. 1 plus 5 is 6. 7 minus 4 is 3. Negative 2 plus 1 is negative 1. 0 minus 1 is negative 1. And 5 plus 0 is 5. So our resulting matrix of these two matrices added together are 8, negative 4, negative 3, 10, 6, 3, negative 1, negative 1, 5. Two matrices can also be subtracted if they have exactly the same dimensions. The difference of the two matrices with the same dimensions is the matrix obtained by subtracting the corresponding elements of the two matrices. So, much like adding matrices, the top left 3 will be subtracted from 5, so 3 minus 5. 2 minus negative 6 is the same thing as saying 2 plus 6. Negative 5 minus 2 is negative 5 minus 2. 6 minus 4, 1 minus 5. 7 minus negative 4 is 7 plus 4. Negative 2 minus 1 is negative 2 minus 1. 0 minus negative 1 is like 0 plus 1, and 5 minus 0, 5 minus 0. So now we can find the difference between these two matrices by simplifying this. 3 minus 5 is negative 2. 2 plus 6 is 8. Negative 5 minus 2 is negative 7. 6 minus 4 is 2. 1 minus 5 is negative 4. 7 plus 4 is 11. Negative 2 minus 1 is negative 3. 0 plus 1 is 1. And 5 minus 0 is 5. And here we have our resulting matrix. So we added and subtracted matrices. Now let's multiply matrices. But there are two types of multiplication associated with matrices: scalar multiplication and regular matrix multiplication, also known as the dot product. Scalar multiplication is the product of a real number and a matrix, so just the whole number and then a matrix next to it. While matrix multiplication, or dot product, is the product of two matrices multiplied by each other. So let's start with scalar multiplication. Scalar multiplication requires multiplying each entry of a matrix by a real number. So if we have matrix A here, which is a 3 by 3 matrix, and we wanted to find 3 times A, that involves us multiplying every element in matrix A by 3. You can think of multiplying matrices by a scalar as distributing the scalar value to each of the terms inside the matrix. So in this matrix, we have 3 times 3, 3 times 2, 3 times negative 5, 3 times 6, 3 times 1, 3 times 7, 3 times negative 2, 3 times 0, and 3 times 5. Our product matrix will be the result of all 9 of these individual products. So 3 times 3 is 9, 3 times 2 is 6, 3 times negative 5 is negative 15, 3 times 6 is 18, 3 times 1 is 3, 3 times 7 is 21, 3 times negative 2 is negative 6, 3 times 0 is 0, and 3 times 5 is 15. Here is our product matrix of 3 times matrix A. Many ask, where would you use matrices in the real world? Well, here we have the records of 5 sports teams at the halfway point in the season. So they've already played half of their games for the season, and they've compiled all their wins, losses, and ties into this list. And we can actually convert this list into a matrix. So as long as we keep all of the elements in the right order, so all the wins are in this column, all the losses are in this column, and all the ties are in this column. And for example, Boston has 21 wins, 10 losses, and 9 ties. That should all be in the same row. Buffalo, the same thing, 19, 17, and 4. And go right through the list: Montreal, Ottawa, Toronto. Now we made our records into a matrix, and we can do some operations for it. So midway through the season, these are the records. You might want to predict what they would be at the end of the season, so when twice as many games have been played. One way we could predict such a thing is to take our matrix that we had of the halfway point in the season and just double it, just assuming that everybody will have the same ratio of wins and losses for the second half of the season. So we can multiply our matrix A by 2, and so 21 times 2 is 42, 10 times 2 is 20, 9 times 2 is 18, 19 times 2 is 38, and we can go right through all the lists and doubling everything, and this would give us some sort of a prediction for what would happen at the end of the entire season. At this point, the second half of the season has been played, and we have the records for just the second half of the season. So the records for the first half of the season are the same, and I put into matrix B the second half of the season records. So these 40 games, how it worked out in the second half of the season. And we can find out what the entire season's records are just by adding these two matrices together. So 21 wins in the first part of the season plus 14 wins in the second part of the season is 35 wins total. 10 losses plus 20 losses is 30 losses, and 9 ties plus 6 ties is 15 ties. So we're adding these two matrices together to get the season's end overall standings. So these are the A plus B standings that were the real actual records at the end of the season. These were our projections, and these are a little bit different. We can actually see how different they are by subtracting the two: the actual records, how many wins, losses, and ties each of these teams had, minus what we projected halfway through the season. And we'll notice that, this team had 7 less wins than we projected, and 10 more losses than we projected, and 3 less ties than we projected. And so now we can actually see how accurate our projection really was. So that was my basic intro into operations with matrices, just addition, subtraction, and multiplying by a scalar. The calculations get a little bit more intense when we start multiplying and finding dot products of matrices, or finding determinants, or using Cramer's rule to solve systems of equations. But this is a good place to start. I think you are ready to start adding, subtracting, and multiplying matrices by scalars. Good luck.